Good morning, students. Today I am going to start the objective questions related to increasing and decreasing functions. Objective questions related to increasing and decreasing functions. Increasing and decreasing functions, monotonic functions object. Monotonic functions. Object. Now the problem. If fx equal to x by 5 plus 5 by x for x not equal to 0 is increasing in the interval. The first option is here minus 5 comma 0. The second option is 0 comma 5. The third option is minus infinity to minus 5, minus infinity to minus 5, union 5 to infinity. The fourth option is minus 5 comma 5, open interval minus 5 comma 5. The given function x by 5 plus 5 by x for x being not equal to 0, x is non-zero real, is increasing in which interval? That is our question. So here f dash x, I will consider the first derivative of the function. F dash x is derivative of x by 5, dy dx of x by 5 plus dy dx of 5 by x. X by 5 derivative of x is 1 by 5 itself. Similarly, 5 into derivative of 1 by x minus 1 by x square. So that 1 by 5 minus 5 by x square, which is x square minus 25 by 5x square. Now the function is increasing. F is increasing. F is increasing implies f dash x is positive. Hence, x square minus 25 by 5x square is greater than 0. That is possible for x square minus 25 is positive because the denominator is positive. Here this is positive, this value is positive. Hence, this one is positive. So that is x minus 5 into x plus 5 is positive. Hence, x does not lies within the interval minus 5 comma 5. Whenever x not lies between minus 5 and 5, x not lies between minus 5 and 5, this inequality valid, hence this inequality valid, hence f dash x is positive, hence f is increasing. Therefore, for x belongs to minus infinity to minus 5 open interval union 5 to infinity, f is increasing. F is increasing in that interval. So the right option is the third option. Here the right option is the third option. Whenever x lies between minus infinity to minus 5 or 5 to infinity only, the given function is increasing. Next one. Next problem. Fx equal to x plus 2 cos x is increasing dash interval. In which interval it is increasing? The options are clear here, 0 to pi by 2. The second one is minus pi by 2 to pi by 6. The third one is pi by 2 to pi, open interval. The fourth one is minus pi by 2 to pi by 2. Fx equal to x plus 2 cos x. Fx equal to x plus 2 cos x is increasing in which interval? In which interval it is increasing? That is our question. Since Fx is increasing, let us consider f dash x. That is d by dx of x plus 2 into d by dx of cos x. Derivative of x with respect to x is 1 plus 2 into derivative of cos x with respect to x is minus sin x. Hence, this is 1 minus 2 sin x. The first derivative is 1 minus 2 sin x. F is increasing, of course, implies and implied. F dash x is positive. 1 minus 2x is positive. 1 minus 2 sin x is greater than 0, which is 2 sin x is less than 1. 1 is greater than 2 sin x. So, 2 sin x is less than 1. Therefore, sin x is less than 1 by 2. Sin x is less than 1 by 2. Since sin x is less than 1 by 2, sin x value, once you consider the quadrants, sin 1 by 2, sin 1 by 2 is nothing but sin pi by 6 is 1 by 2. Sin pi by 6 is 1 by 2. So, up to from 0 to pi by 6, up to from 0 to pi by 6, x is less than, because sin 0 is 0, sin pi by 6 is 1 by 2. So, sin x varies from 0 to 1 by 2 whenever x varies from 0 to pi by 6, 0 to pi by 6. Moreover, x takes negative values also. Here sin x less than pi by 2 means 1 by 2 means sin 1 by 2 less than 1 by 2. Maximum value of sin is 1 and minimum value is minus 1. So, sin x less than 1 by 2 means it takes the values which lies between minus 1 and 1 by 2. So, therefore, here sin x lies between minus 1 and 1 by 2. Minus 1 and 1 by 2. Since sin x is less than 1 by 2, it may takes the values less than 1 by 2 until minus 1. Sin x lies between minus 1 and 1 by 2 means minus pi by 2 is less than, x is less than pi by 6. So, minus pi by 2 means in fourth quadrant. This is minus pi by 2. From minus pi by 2, from this onwards, it is from minus 1 to 0, 0 to 1 by 2. So, hence, whenever x lies between minus pi by 2 to pi by 6, sin x is clearly less than half. In such case, f dash x is greater than 0. Hence, for x belongs to the open interval minus pi by 2 to pi by 6, f is increasing. F is increasing. The second option is the right option. The second option is the right option. Next problem. In the interval open interval 7 to infinity, that means x is more than 7, the function f(x) equal to mod x minus 5 plus 2 into mod x minus 7 is, the first option is increasing, the second option is decreasing, the third option is constant, the fourth option is cannot be estimated. Cannot be estimated. Cannot be estimated. In the interval 7 comma infinity, in the interval 7 comma infinity, the given function is now given x belongs to 7 to infinity. The nature of the function is to be discussed in that interval. That means x is more than 7. That implies x more than 7. Hence, x minus 5 is positive, as well x minus 7 is also positive. Both x minus 5, the value inside the modulus is positive. The value inside this modulus is also positive. Both x minus 5, x minus 7 is positive whenever x greater than 7. Therefore, mod x minus 5 is x minus 5 and mod x minus 7 equal to x minus 7, because modulus of the positive quantity is itself. Mod 2 is 2. Mod x for x greater than 0 is x. Hence, modulus of x minus 5 is x minus 5, because x minus 5 is positive. Mod x minus 7 is x minus 7 itself, because x minus 7 is positive. So, both mod x minus 5 and mod x minus 7 is positive. X minus 5 and x minus 7 itself. Hence, f(x) takes the value, the given function becomes mod x minus 5 is same to that of x minus 5 plus 2 into mod x minus 7 is same to that of x minus 7. So that the given function is x plus 2x, 3x, minus 5 minus 14, minus 19. This is our f(x) for x greater than 7. So, therefore, here f dash x is clearly 3. The derivative of x is 1, derivative of constant is 0. So, f dash x is 3, positive. Hence, when x more than 7, then f dash x is positive implies f is increasing. F is increasing. So, the function is increasing for that values of x. Similarly, another problem, same model. If 15 is less than x is less than 30, then f(x) is mod x minus 15 plus mod x minus 30 is, the options are increasing, decreasing, constant, and fourth one is cannot be estimated. Cannot be estimated. Estimated. Here is also the interval is given. x particularly lies between 15 and 10 only, you have to discuss the nature of the function. For those values of x only, you have to discuss the nature of the function. The monotonic nature of the function is to be discussed in that interval. So 15 is less than x is less than 30 implies x minus 15 is negative clearly. X is more than 50, x is more than 15. So this is more than 15, x is more than 15, hence it is positive, of course, it is positive. X minus 15 is positive and x is less than 30, hence x minus 30 is negative. This is positive and this is negative. So mod x minus 15 is x minus 15 itself and mod x minus 30 is minus of x minus 30. By definition of the modulus function, by definition of the mod k is k, for k positive, minus k for k is negative, 0 for k is 0. So this is the definition of the mod k. With the help of the definition of the modulus function, this value is negative, hence its modulus is minus of x minus 30, which is 30 minus x. Therefore, here f of x, the function is here f of x. Therefore, f of x is mod x minus 15. Mod x minus 15 is x minus 15 itself plus 30 minus x. Modulus of x minus 30 equal to 30 minus x when x lies between 15 and 30. For 15 is less than, x is less than 30. So here x cancel. Hence fx is constant 15 when x belongs to 15 comma 30. X lies between the interval, x takes all the values that lies between 15 and 30. Fx is always constant function. So graphically between x is 15 and 30, the graph of the function is constant, which takes the value 15, which takes the value 15. In this interval, the graph of the function is parallel to x-axis because it is constant function. Therefore, f dash x is here 0 for all x that lies between 15 comma 30. Constant derivative is 0. Hence, the function is stationary. The function is stationary. We cannot say either it is increasing or decreasing. So, you can say that it is constant. It is constant. Hence, therefore, the derivative is 0. Hence, therefore, f is constant function. F is constant function for x belongs to 15 comma 30. That is to be observed here. It is a constant function. Next one. Next problem. If x greater than 0, x being positive, then the interval of monotonically increasing of f x equal to 2x square minus log x is the interval in which the function is monotonically increasing. That is the question. once x is positive, and fx is given as 2x square minus log x, for in which interval the function is monotonically increasing. So, given fx is here 2x square minus log x to the base. Therefore, f dash x, the first derivative is differentiating with respect to x, x square is, derivative of x square is 2x, hence 4x, minus derivative of log x is 1 by x. On simplification, 4x square minus 1 by x. F is increasing, f is monotonically increasing. Then f dash x is positive. Therefore, 4x square minus 1 by x is positive. But given x is positive, the denominator is positive. Therefore, the numerator is positive. Since x is positive, 4x square minus 1 is greater than 0. Once 4x square minus 1 is greater than 0 only, the function is monotonically increasing. That is 2x minus 1 into 2x plus 1 is greater than 0. 2x minus 1 into 2x plus 1 is greater than 0. So, therefore, x does not lies between minus 1 by 2 and 1 by 2. This inequality valid whenever x does not lies within the interval. Once x does not lies in between these values only, either x less than minus half or x greater than half, only this inequality valid. Because in this interval, both the factors are positive, positive into positive. In this interval, both the values are negative, negative into negative, positive. So, in between minus 1 by 2, 1 by 2, if x lies, then it gives us negative. But here we are in need of positive values. So, hence in this one, f dash x is positive. Here is also f dash x is positive. Here f dash x is negative. So, therefore, for x belongs to minus infinity to minus 1 by 2, union 1 by 2 to infinity, f is increasing, monotonically increasing. So, in that interval only it is increasing. But you cannot take x is negative, because here given x is positive. You cannot take these values. Therefore, for x belongs to 1 by 2 to infinity only, f is increasing. You cannot take x which is less than minus half, because x being positive, since x greater than 0. So, hence, whenever x is more than 1 by 2 to infinity, the function is monotonically increasing. Next one. Next problem. The set of values of A. The set of values of A for which fx equal to x cube minus ax square plus 48x plus 1 is increasing for all real values of x. For all real values of x. For all real values of x, once the function is increasing, then you have to find the set of values of a. For what values of a? It is increasing. It is increasing. For this, let us consider f dash x here, the first derivative. The derivative of the given function. Derivative of x cube is 3x square. Derivative of x square is 2x, hence minus 2ax. Derivative of 48x is 48. This is the first derivative, a second degree function. 3x square minus 2ax plus 48. The function is increasing. F is increasing. F is increasing implies f dash x is greater than 0 for all x. That implies 3x square minus 2ax plus 48 is greater than 0 for all x. That belongs to R. Once the quadratic is more than 0, the quadratic is more than 0. Graphically observed, every quadratic represents a parabola. So this parabola takes the functional value, the parabola takes only positive value. That means it is above x-axis only. Once you draw the parabola of this curve, it is above the x-axis like this, because a is positive, x square coefficient is positive, and total functional value is positive. So 3x square minus 2ax plus 48 represents a parabola which is completely above the x-axis. It never crosses x-axis. It never comes down to the x-axis. Neither it crosses the x-axis nor come down the below the x-axis. It is the graph of this function. The graph of this function, f dash x quadratic, is completely above the x only because it is positive, and the x square coefficient is also positive. Hence, it has no real values. This quadratic has no real roots, because once it has real roots, the graph is like this. Once the graph is like this, it intersects the x-axis. There it has real roots. But here, this is positive. It never crosses x-axis. Hence, it is completely above the x-axis. The graph of this quadratic is above the x-axis only. Hence, it does not have real roots. Once this quadratic has no real roots, then its discriminant is negative. So this is possible. This inequality is possible. For the discriminant delta of 3x square minus 2ax plus 48, that is delta equal to, discriminant of this one is b square minus 4ac. b square means minus 2a whole square minus 4ac, minus 4 into 3 into 48 is negative. So this inequality follows for all real values of x. For all real values of x means whatever may be the value of x, completely the graph is above the x-axis because positive. Hence, that is possible whenever delta is less than 0. That gives us 4a square minus 4 into 24 means 144 is less than 0. 3 into 48 gives us 144. You can remove 4 here. So a square minus 144 is less than 0. Therefore, a minus 12 into a plus 12 is negative, which is possible for a belongs to minus 12 and Once a lies between minus 12 and 12 only, the inequality a minus 12 and a plus 12 is less than 0. So, the values of a, the set of values of a lies between minus 12 to 12 whenever the function is increasing for all real values of x. So, this is the, therefore, minus 12 is less than, a is less than 12 follows. These are the values of a in which the function is increasing. Next, fx equal to mod x is increasing in which interval? Minus infinity to infinity. The second option is minus infinity to 0. The third one is 0 to infinity. Fourth one is minus infinity to minus 1. Fx equal to mod x is increasing in which interval? I will explain this problem graphically. Given fx equal to mod x, the graph of the mod x is like this. It is in V shape, passing through origin and completely above x axis only. Once x being positive, this is x for x greater than 0 and minus x for x less than 0, 0 for x equal to 0. That means it clearly passes through 0, 0 origin, and for x more than 0, x is positive, the graph is y equal to x, This is the function for x being fx equal to x, y equal to x graph, which is a straight line making 45 degrees angle with the positive direction of x axis. Similarly, fx equal to minus x for x negative. That means this is 45, otherwise this is 135. So, this is fx equal to minus x, So, this is the graph of the function fx equal to mod x, which is in the shape of V and passes through origin. So, clearly from 0 onwards, from 0 to infinity, the graph is increasing because these vertical lengths are increasing as x increases. But whereas here, as x increases from minus infinity to 0, these vertical lengths are decreasing. Hence, in this interval it is decreasing, in this interval it is increasing clearly. From the graph you can conclude that. So, from the graph, if x lies between 0 to infinity, then f is increasing, and whenever minus infinity is less than x is less than 0, then f is decreasing, and it takes stationary value at x equal to 0, So, the function is increasing whenever the values of x lies between 0 to infinity. It is decreasing in the interval minus infinity to 0. Next, such problems can be evaluated through graphically. Next one. Fx equal to root over x square minus 4 is decreasing in the interval. Decreasing in the interval, the options are minus 2 comma 2. The second option is 2 comma infinity. The third option is here minus infinity to minus 2. The fourth option is minus infinity to infinity. The given function fx equal to square root of x square minus 4. X square under root x square minus 4 is decreasing. In which interval? Given fx is square root of x square minus 4. X square minus 4. So, f dash x, the first derivative f dash x is derivative of root function is 1 by 2 into root over x square minus 4, and derivative of x square minus 4 follows by function of function rule. At first find the derivative of the square root function, which is 1 by 2 into root x square minus 4, and derivative of x square minus 4 follows. That is 1 by 2 into square root of x square minus 4 into 2x. For x square it is 2x, for constant 0. So, you can remove 2. Hence, f dash x is x by root over x square minus 4. But f is real valued function. But f takes real values when x square minus 4 is greater than or equal to 0. That is x minus 2 into x plus 2 is greater than or equal to 0. That is x does not lies between minus 2 and 2 only, it is possible. So, the domain of the function is therefore domain of f equal to minus infinity to minus 2 union 2 to infinity. Only x must take these values. So, in these values x square minus 4 is greater than 0 or equal to 0. Whenever x is minus 2, the denominator is 0. So, x cannot take the value minus 2. Whenever x equal to 2 also, the denominator is 0. The denominator cannot be 0 in f dash. So, you have to exclude these end values here. Other than the values minus 2 and 2, for remaining values it is clearly positive. This one is positive, positive square root. Hence, x takes the value based on x, f dash x may be positive or negative. So, whenever, therefore, I will conclude like this. For x is more than 2, x greater than 2, x is more than 2 up to infinity, 2 to infinity, then x square minus 4 is positive and x is also positive. X more than 2 means both x and x square minus 4 is positive. Therefore, x by square root of x square minus 4 is positive. F dash x is positive for x greater than 2. So, therefore, in the interval 2 to infinity, f is increasing. F is increasing function. In 2 to infinity, f is increasing function. For x is negative, though it is positive, it is negative. So, negative by positive gives us negative. In such case, f is decreasing, not increasing. But here we are in need of decreasing, of course. Decreasing means the value must be taken negative. Similarly, you can take like this. Similarly, for x less than minus 2, f dash x is negative, hence f is decreasing. So the required answer is actually this one. The required answer is 3, not 2. It is increasing in 2 to infinity, whereas whenever x lies between minus infinity to minus 2, it is decreasing. The function is decreasing. Next problem. Fx equal to square root of 100 minus x square. Fx equal to square root of 100 minus x square is increasing in dash interval. In which interval it is increasing? This is also same to that of the previous problem. Once find the domain of the function here. Fx is here square root of 100 minus x is defined for 100 minus x square is greater than or equal to 0, which implies 10 minus x into 10 plus x is greater than 0. So x belongs to minus 10 and plus 10. The domain of the function is minus 10 comma 10. In that interval only the nature of the function to be discussed here, so that from minus 10 to 10 only we have to observe the monotonic nature of the function. Now coming to f dash x. F dash x is dy dx of root over 100 minus x square. This is 1 by 2 root of 100 minus x square into dy dx of 100 minus x square. For the square root function, the derivative is 1 by 2 root of 100 minus x square, and dy dx of 100 minus x square follows. That is 1 by 2 into square root of 100 minus x square into minus 2x, which is minus x by root over 100 minus x square. You can remove these two. Whenever x is positive, and less than 10, because x lies between minus 10 and 10. Whenever x is positive, x lies between minus 10 and 10. X is positive means x is more than 0 and less than 10. In this interval, clearly f dash x is negative. Once x is positive, because of minus, it is negative. F dash x is negative. Whenever x is negative, negative of negative, positive, in this interval f dash x is positive. So in this interval, f is increasing, whereas in this interval f is decreasing. So hence we are in need of increasing nature of the function here. Therefore we can conclude that x belongs to 0 comma 10. For x equal to 10, the derivative does not exist. Hence I am not taking 10. X belongs to 0 to 10, then f dash x is negative, and for x belongs to minus 10 to 0, f dash x is positive. Therefore f is increasing in the interval minus 10 comma 0, increasing in the interval minus 10 comma 0. So the right option is, answer is here, the answer is minus 10 comma 0. Whereas the function is decreasing in other interval 0 to 10, because f dash x is less than 0 in such case. You can observe this function through graphically. I will draw the graph of this function f(x) equal to root over 10 minus x square. So, the graph of the function, let us consider y equal to square root of 100 minus x square. Squaring 100 minus x square is y square. So, that x square plus y square equal to 100. Only I am taking positive sign to y. Hence, it gives us x square plus y square equal to 100 is a circle, complete circle. But whereas taking y equal to only square root of 100 minus x square is semicircle, which is completely above the x axis. So, the graph is like this. The graph is like this. This is x axis, this is y axis, and whereas this is y equal to square root of 100 minus x square is our graph, the semicircle above the x axis, whose radius is 10. Whose radius is 10 means this radius is 10 units, this radius is 10 units. This is minus 10 comma 0, this is 10 comma 0, because it lies in the positive axis, it lies on the negative axis. That's why I am taking this point as minus 10 comma 0, this point as 10 comma 0, this point as, this is also radius, y equal to 10, y equal to the length equal to 10, x is 0. So, this is 0 comma 10 only. These are the points of semicircle which meets the coordinate axis. Now, once you consider for these values of x, x lies between minus 10 and 0, x lies between minus 10 and 0, the vertical lengths are increasing, these values are increasing. Hence, in this interval, the function is increasing up to 0, and then it comes down. That means the vertical lengths are decreasing, hence this is decreasing in this interval 0 to 10. That's why whenever x lies between 0 and 10, the function is decreasing order, f dash x is negative. Whereas whenever x lies between minus 10 and 0, f dash x is positive, hence the function is increasing. Hence the right option is minus 10 comma 0, in which the function is increasing. Next one. Next problem. Fx equal to log of 1 minus x square to the base is increasing in, the options are given, minus 1 comma 0, 0 comma 1, minus 1 comma 1, fourth one is 5. 5 stands for null set. So, fx equal to log 1 minus x square is increasing in which interval? So, given fx equal to here log 1 minus x square to the base. Therefore, first derivative f dash x is derivative of the function log of 1 minus x square to the base. Log 1 minus x square derivative. For the logarithmic function, the derivative is 1 by 1 minus x square. Of course, again the derivative of 1 minus x square follows by function of function rule. So, derivative of 1 is 0, derivative of x square is 2x, hence we get minus 2x here, that is minus 2x by 1 minus x square, which is 2x by x square minus 1. This is f dash x. I am taking this negative sign to the denominator, so that f dash x is 2x by x square minus 1. Now, f dash x is positive because f is increasing. F is increasing when f dash x is positive. Therefore, 2x by x square minus 1 is positive. Here, therefore, 2x into x square minus 1 by x square minus 1 whole square is positive. Taking the product of x square minus 1, multiply the numerator and denominator with x square minus 1. It is 2x into x square minus 1 by x square minus 1 whole square is positive. Clearly, it is a perfect square positive. This is positive. Hence, this must be positive. Therefore, x into x square minus 1 is positive. Therefore, x into x minus 1 into x plus 1 is positive. From this, x may be 0 here, x may be minus 1 here, x may be 1 from these factors. Now discuss the nature of the function in these intervals for less than minus 1, for more than 1, once it lies between minus 1 and 1, like that. Suppose x is more than 1. X more than 1, this is positive, this is positive, this is positive. X more than 1, then f dash x is positive clearly. Here is positive. F dash x is positive. X lies between minus 1 and 1. Minus 1 and 1. Otherwise 0 to 1. X lies between 0 and 1. This one. X positive, x minus 1 negative, x plus 1 positive. So 1 is positive. This is positive. This is negative. So positive, negative, positive. So negative. F dash x is negative. Similarly, whenever x lies between minus 1 and 0, whenever x is less than 0 and more than minus 1, x is negative because less than 0, x is negative. X minus 1 still negative. X plus 1 positive. Negative, negative, positive. So positive. In this case, x less than minus 1, x less than minus 1, this is negative, this is negative, this is also negative, hence totally negative. So in different intervals, f dash x takes different signs. Whenever x more than 1, f dash x is positive. Whenever x lies between 0 and 1, f dash x is negative. Whenever x lies between minus 1 and 0, f dash x is positive. For x less than minus 1, f dash x is negative. So based on this, the value of x is here. Since f dash x is positive, valid only in case of minus 1 and 0 and more than 1. So therefore, x belongs to minus 1 comma 0 union 1 to infinity. But whenever x more than 1, this is negative. Logarithm is not defined. So it cannot be valid. That should be observed. The taken values must be within the domain of the function. So log function, log 1 minus x square is defined for x belongs to minus 1 comma 0 minus 1 comma 1. Hence the required interval is in which f dash x is positive, that means f is increasing, is the required interval is minus 1 to 0. That is the right option. F x equal to log 1 minus x square is defined. The domain of the function is minus 1 to 1 itself. So the argument should be confined to that interval. So since the argument is confined to only minus 1 to 1, I am taking this value only. Okay, I am leaving this part. At every moment, we have to consider the domain of the function, where for what values of x the function is defined. That should be observed. Beyond the domain of the function, we should not discuss the nature of the function. Within the domain of the function only, we have to discuss the nature of the function, monotonic nature of the function. This is one more interesting question. Fx equal to 25 plus mod x minus 9 is increasing in dash interval. In which interval the function fx equal to 25 plus modulus of x minus 9 is increasing. Here fx equal to 25 plus modulus of x minus 9. This x minus 9 is positive for x more than 9. Hence, in such case, that means for x greater than 9, the function is 25 plus x minus 9 for x being greater than 9. Once it is positive, this value is positive, modulus value gives us x minus 9 itself. Once x is negative, less than 9, it is clearly negative. So, for x less than 9, this is negative, hence we get minus of x minus 9, because this is negative in such case. For x equal to 9 in particular, for x equal to 9, it is vanished. So, fx takes a constant value 25. So, therefore, the given function is nothing but 25 minus 9. 25 minus 9 gives us 16 plus x. This is for x greater than 9, and this is 25 plus 9. 34 minus x for x negative, and this is constant 25 for x is 9. This is the function, actual given function, once you evaluate the function. So, therefore, f dash x is derivative of this part is 1. This is for x greater than 9. The derivative of this function is minus 1. For x less than 9, the derivative of constant function is 0. This is for x equal to 9. That is the derivative of the given function. In different intervals, x more than 9, f dash x is 1 positive. X at less than 9, in this interval, f dash x equal to minus 1 negative. At 9, f dash x is 0. F dash x is positive, then f is increasing. So, f is increasing clearly when f dash x is positive, x greater than 9. So, that therefore, f is increasing function for x greater than 9, that is for x belongs to 9 to infinity. This is the interval in which a function is increasing. Suppose similarly, you can conclude that f is decreasing for x negative, that is for x belongs to minus infinity to 9 here. In this interval, f is decreasing. At 9, f dash x is 0, hence it is stationary. So, here the required interval, since we are in need of increasing nature, This is the answer. This is the answer. 9 to infinity is the required interval in which x lies, where the function is increasing. Okay, I will come up with certain problems in the next class.